Hello students, how are you? I hope you are fine and enjoying. You might have gone through my first lecture that is on formula making. So that was just a basic concept. Today we are starting with the syllabus. And we'll start with the first chapter in physics, that is motion. 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 Now, when is a body said to be at rest? When do you call that the body is rest? A body is said to be at rest if it does not change its position with respect to its surroundings. A body is said to be at rest when it does not change its position with respect to surroundings. What do you mean by the word with respect to surroundings? Supposing this is your house and you are sitting here. If with time you do not change your position and you remain here at 11 o'clock, 12 o'clock, 1 o'clock, etc., in that case you will be said to be at rest. A body is said to be at rest if it does not change its position with respect to time. Now, when is a body said to be in motion? Body is said to be in motion if it changes its position with respect to its surroundings. With respect to time, it changes its position. Now, supposing at 11 o'clock you are 1 kilometer from your house and at 12 o'clock you are at 2 kilometers from your house. That means you are in motion. You are continuously changing your position with respect to the house. That is the body is said to be in motion. So, body is said to be at rest when it does not change its position with respect to time, and it is said to be in motion if it changes its position with respect to time. Is that clear? Do you now know what rest is and what motion is? Now moving on to the first topic in this chapter, an important one. What are scalar quantities? What are scalar quantities? Those quantities which require only magnitude and no direction for their complete description are called scalar quantities. I will explain to you what scalar quantities are. Those quantities which require only magnitude and no direction for their complete description. That means they are magnitude related properties. For example, distance is a scalar quantity, speed is a scalar quantity, time is a scalar quantity, work done is a scalar quantity, and so on. So these are scalar quantities. Nobody asks you what's the time. You say it's 11 o'clock. You don't say towards south, towards north, towards west. No, there's no need to describe time with direction. Same is the case with distance. 3 kilometers. 3 kilometers in any direction is the distance. So these are scalar quantities. So these quantities require only magnitude and no direction at all. So these are scalar quantities. Moving on to the vector quantities. Now, what are vector quantities? Vector quantities. Vector quantities. They require both magnitude as well as direction for their complete description. For example, displacement, velocity, force, etc. These are all, or energy for that matter, they are all vector quantities. They require direction for their complete description. If I say, I moved 2 kilometers from a house towards north. Towards north is the direction specified. So that will be the displacement from my house. Is that clear? So that is, these are vector quantities. They require magnitude as well as direction for their complete description. You'll get the definitions only and the examples of such properties. Moving on to the next topic, we'll move on to distance. What is distance? Distance. What is distance? Distance is the actual path traversed by the body between 2 points. Distance is the actual path traversed by the body between 2 points is called the distance. Supposing you start moving from your house towards your school and you traverse a path of 3 kilometers. So 3 kilometers is the distance. It is not a direction related property, so it is a scalar quantity. No direction is specified in this. So distance is a scalar quantity and it is the actual path traversed between 2 points. This is a scalar quantity. This is a scalar quantity. Then a similar type of thing, but that is a vector, displacement. Displacement. It is the shortest distance between 2 points. It is the shortest distance between 2 points is called the displacement. Distance can be, you can go to your school through one street covering 3 kilometers or from the other street covering 4 kilometers. Distance in each case will be different. But if the shortest distance is 3 kilometers, then this 3 kilometers, the shortest path traversed will be called the displacement. Do you understand what the difference between distance and displacement is? You'll get it in the paper also. Distance is the actual path traversed. Displacement is the shortest path between 2 points, between the initial and the final positions. Initial and the final positions. Distance is a scalar quantity, while displacement is a vector quantity. So displacement is the shortest path traversed between initial and final position. I'll just explain to you with the help of an example. This is a vector quantity. You'll get two differences between distance and displacement. Write the definition of distance, write the definition of displacement, and then write it is a scalar quantity, it is a vector quantity. To make the concept very clear, I'll show you an example. Please look at this. Supposing this is point A, this is point B. A body moves from point A and covers a distance moving through path A. Path A, the distance is 4.5 kilometers. Path B, distance is 6.5 kilometers. And then the body moves through path C. Path C distance is 3 kilometers. Now you very well know that if you move through 3 different paths, along 3 different paths, the distance in each case will be different. That means distance is actually what your feet have traveled if you are moving on foot. Distance is that, the actual path traversed. So distance is different for 3 different paths. But what about displacement? Displacement is the shortest distance between initial and final position. Now, if you're moving from A to B, what is the shortest distance? The shortest distance is 3 kilometers between A and B. So what will be the displacement in this case? Displacement will be 3 kilometers. If I take it in kilometers. Is that clear? So this is the shortest path traversed between 2 points. So what is the SI unit of distance, as the magnitudes are the same, distance and displacement? The SI units are meters. If you take it in kilometers, 1 kilometer is equal to 1000 meters or 10 raised to power 3 meters. SI unit of distance displacement are meters. 1 kilometer is equal to 1000 meters or 10 raised to power 3 meters. Is that clear? Moving on to another example. So this is what displacement and distance is all about. We'll be doing a lots of numericals on this case. Another example. If a car starts from point A and moves to point B covering a distance of 10 meters. Now this car returns from B by a distance of 3 meters at point C. So this was 10 meters. And this is 3 meters. Now what will be the distance? The actual path traveled by the car. So what will be distance in this case? I hope you might have calculated this. Distance is 10 plus 3 is equal to 13 meters. 10 plus 3 is equal to 13 meters. What about the displacement? Displacement is the shortest distance between initial and final position. What is the shortest distance between initial position A and final position C? You might have calculated. You are intelligent enough to calculate this. The shortest distance is this. So that will be 10 minus 3. Because it has moved in the opposite direction, that will be subtracted. So this will be 10 minus 3 will be 7 meters. So what will be the displacement? Will be equal to 10 minus 3 is 7. Now how has this 7 come out to be? Because the final position is C and not B. And the shortest path between the initial and the final position can be calculated from here. 10 minus 3, 7. Okay. Now, in the same case, if A to B, supposing this is 10 meters and the body returns back through the same path covering 10 meters again. Now, what will be the distance? Distance traveled is the actual path traveled by the body. That is 10 plus 10 is equal to 20 meters. But what about the displacement? The shortest distance between the initial and the final position. What is the initial position? A. What is the final position? A. So what will be displacement? You might have calculated what is displacement. Is 0. Is 0. Why is displacement 0? Because initial and the final points are same. So that is what displacement and distance. So that means displacement can be 0, distance cannot be 0. When will displacement be 0? If a body moves from one point to the other and along the same path it moves from the other point to the first point. In that case, supposing this is 10 kilometers, if you take the positive direction as 10 kilometers because it is the direction related property, positive, this is 10 meters, this is positive and it returns back the same path towards A, this will be minus 10. 10 minus 10 is 0, or to be very precise, initial point and the final point are A, so displacement is 0. Have you understood? We'll now move on to some numericals. Have you understood this? You might have understood this. For any problems, We'll probably have a live session in the weekend through an app, and then we'll discuss more and more questions. Keep on compiling these questions, writing more and more questions so you can take queries from me in the weekend. Okay? Then is a question, a very important question. See this diagram. This is the center. This is a circle with radius 7 meters. Radius of the circle is 7 meters. A man starts moving from A and then completes one round and comes back. This point is position B. Now, a man starts from A along this path. Okay. Now the question is, what will be distance after one round? And second, what will be displacement after one round? Distance. When a body is moving around a circular field or a circular path, the distance is given by the circumference of the circle. You might have done it in your maths class. Circumference. So distance is equal to circumference is equal to 2 pi r. 2 pi r. So what will be distance equal to? 2 into pi is 22 by 7. You might be knowing it. You can take it as 3.14 also, or 22.7 into 7. So that is equal to 44. 2 pi r. 2 pi r, 44 meters is the distance traveled. This is the actual path traveled by the body along a circular path. The circumference will give the distance traveled. Now, very important thing. What about the displacement? What about the displacement? What was initial point? A. What was final point? After one round? After one round is also A. So what is the displacement? Though the person has completed the whole circle, but then even displacement is 0. Displacement is 0, initial point, and then it comes back to A. So the displacement is 0. Have you understood the difference between distance and displacement? Distance being the actual path traveled and displacement being the shortest distance between the initial and the final positions. Moving on to more examples. I will be doing lots and lots of examples so that you don't need to do other things. Now see, in the same case, another question from circle. Another question from circle. Supposing this is the circle of radius 21 meters. This is A, this is B, this is C, and this is D. A man moves from A towards B. This is given. A towards B. Question is, what is the distance after 2.5 rounds? What is the displacement after 2.5 rounds? Distance after 2.5 rounds and displacement after 2.5 rounds. Now, moving on to the distance. Distance is the actual path traversed. How will the body move? The man will move from A, this is one circle, one round, two rounds, three rounds, and then it will reach C. 3.5, so 2.5 rounds, 1, 2, and then half a round. So the final position of the man will be C. The final position of the man will be C. So that means the person has made 2.5 rounds. That means distance will be equal to 2.5 into circumference, because circumference is the distance of one round, is equal to 2.5 into 2 into pi, 22 by 7 into r, 21. So 7 3s are 132, 2.5 into 132. This will be 264 and 66. 300 and 2.5 into 132 will be 330 meters. 330 meters. This was 2.5 into circumference. The formula of the circumference is 2 pi r. That is the radius, 21. That I have put here. That comes out to be 330 meters. Is that clear? Now, to the displacement. Displacement. Shortest distance between the initial and the final position. Initial is A, final is C. What is the shortest path between A and C? A and C. Shortest path between A and C is equal to the diameter. Is equal to the diameter 1, 2, 2.5. Where has the man reached now? The man has reached C. So this was 21, this is 21. So what will be this equal to? For 21 plus 21 is equal to 42 meters. So what will be the displacement? Displacement is the shortest path between initial and final position. That will be 42 meters. Is that clear? Now, for the distance, you had calculated the total path traversed. But for the displacement, it is the distance between the shortest distance between the initial and the final points. I hope you understand. If you feel that I am going a bit fast, you can WhatsApp me for your problems. If you face any problems in the audio and visual quality, then you can WhatsApp me. Improvements can be made in this also. Okay. Now moving on to the other numerical. The next numerical. Next numerical regarding distance and displacement is, supposing you have a square. You have a square of side 40 meters. Now if it is a square, all the sides will be 40, 40, 40 and 40 meters. Am I right? It's a square. It is a square. A person starts from A, B, C and D. A person starts from A. A person starts from A. Calculate distance after 4 rounds, distance after 1.5 rounds, displacement after 4 rounds, and displacement after 1.5 rounds. So this will be a 3 marker you will get. Distance after 4 rounds, distance after 1.5 rounds, displacement after 4 rounds and displacement after 1.5 rounds. Now, distance after 4 rounds. 1, 2, 3, 4. 1 round is equal to the perimeter. Is equal to the perimeter of the square. So, and distance is 4 rounds. So that means distance will be equal to 4 into the perimeter. Perimeter is 4 into S. Is equal to 4 into S. 4 into 4S, where S is the side of the square, is equal to 4 into 40. 640 meters. Distance after 4 rounds will be 4 into perimeter. Perimeter is 40 plus 40 plus 40 plus 40. That is 4 into side. Where S is the side, 4 into 40 into 4 rounds is 40 meters. Then is distance after 1.5 rounds. Distance after 1.5 rounds. 1 round and 1.5 round. That will be, distance will be equal to 1.5 into perimeter is equal to 1.5 into 4 into 40. That is equal to, I think, 240 meters. 240 meters. 40 plus 40 plus 40 plus 40 and then 40 plus 40. So 6 times 40, 240 meters. Okay. Displacement after 4 rounds. 1, 2, 3, 4. What is the initial position? Initial position is equal to A. Final position after 4 rounds is A. So what will be displacement? Will be 0. See, the distance after 4 rounds is 640. But the displacement is 0 because the person started from A and reached A. So this is displacement after 4 rounds. Now, displacement after 1.5 rounds. Displacement after 1.5 rounds. This is the fourth part rather. Displacement after 1.5 rounds. One round is this, 1.5 is this. So what is the initial point? A. Final point after 1.5 rounds is C. So what is the shortest distance? The diagonal of the square? The diagonal of the square is the shortest distance. Shortest distance is distance between A and C is equal to diagonal of square. How do you calculate the diagonal? You might have done the Pythagoras theorem. Hypotenuse square is equal to base square plus height square. So let it be x. Applying Pythagoras here, Pythagoras, this distance, this displacement x. Applying Pythagoras, you might have done theorem. What do you get? X square is equal to 40 square plus 40 square, or x square is equal to 1600 plus 1600. X square is equal to 3200. So what will be x equal to square root of 3200. 100 का रूट 10 आ गया, 16 का 4 आ गया, 2 रूट में रह गया, is equal to 40 root 2 meters. This is the displacement. What is the displacement? The shortest distance between A and C, no matter how many rounds you have crossed, but whenever you stop at the final point, you have to calculate the distance from where you started and the distance from where you have reached. Is that clear? So that is 40 root 2 meters. This is what distance and displacement is all about. In the next class, we'll start with speed. What is speed? Average speed, a bit of numericals from average speed, and then we'll start with velocity, distance time curves, velocity time curves, derivation of equations. So that is, this chapter is a bit longer. It may take about 6 to 7 classes in this chapter, but do this. Try some questions from your NCERT. The study material will be mailed to you. Okay, so this you have to study. Okay, bring the video to the pause mode, listen to what I have said, and then try solving these numericals, taking the questions down only from the video. Thank you very much.